Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The rate constant, K, of a reaction is related to the activation energy, E, by the Arrhenius equation, K is equal to A.exp, E RT. The activation energy is the energy difference between the transition state and the reactants, E is equal to E, transition state, E, reactants. Moving on to the next step. Effect of reactant stability on rate constant. If the stability of the reactant is increased, the energy of the reactant ground state decreases. This increases the energy gap between reactants and the transition state, thereby increasing E and decreasing K. Conversely, if the stability of the reactant is decreased, the energy of the reactant ground state rises, making the energy gap smaller, lowering E and increasing K. Therefore, A is equal to decreasing. Moving on to the next step. Effect of transition state stability on rate constant. If the stability of the transition state is increased, the energy of the transition state decreases. This reduces the energy gap, E, between reactants and the transition state, thereby decreasing E and increasing K. Therefore, B is equal to increasing. And for the final step, combining both conclusions. A is equal to decreasing, B is equal to increasing, which corresponds to option C. Why other options fail? A. Decreasing T's stability would raise E and lower K, so B cannot be decreasing. B. Increasing reactant stability raises E and lowers K, contradicting the premise, B is equal to decreasing also lowers K. D. Increasing reactant stability raises E and lowers K, not increases it. Therefore, the correct answer is C. Therefore, the correct answer is option C.